Bienvenidos, Ushamdi, and welcome CMIT 454, sections 6380 and 6382 for the first 8-week term of the spring 2018 semester at the University of Maryland University College. This is the CCNA Security version 2.0 course from the Cisco Networking Academy, and this morning's video tutorial is going to be a continuation on our conversation about iOS firewalls, right, and how we can protect a Cisco iOS router specifically. And so this supplement focuses on CBAC, and this was commonly referred to as iOS Classic Firewall. And so now we're going to continue to build on that previous conversation of the standard ACLs, the extended ACLs, the TCP intercept, reflexive ACLs, and now we're going to move into CBAC. And Chapter 4 in our online material does a fantastic job in covering this, but we need to point out that there have been some changes. And so we're going to be talking about some of the changes that aren't reflected in the new material to make sure that we're clear on that. And we'll actually see everything from the command line. So as a brief review, let's go ahead and pull the whiteboard up here, and let's change our color out here to yellow, which comes off a little bit better on the screen. Let's make sure, yeah, it's yellow. All right, so remember our conversation. We started out with our standard ACL, and I'm really trying to drive this point home. The standard ACL was stateless, so I'll just put SL for stateless, and it was limited to layer 3, and layer 3 only the source information. So the standard ACL was stateless, it was layer 3 only, right, which meant the IP address, and you could only filter based on the source address. So then Cisco said, you know what, that's not good enough. We need to come up with something better to give us more functionality. So then they came out with the extended ACL. And again, it was stateless, right? It maintained no state information, and you could work with the layer 3 and the layer 4 information, right? And you could do it on source, destination, port, protocol, right? So it gave us much more functionality. But these are still nothing more than packet filters, and because they're stateless, we are still stuck looking at every packet, right? Packet by packet, we simply look in either at the layer 3 information, or we look at the layer 3 and layer 4 information that we're dealing with. So then Cisco said, well, you know what? It would be nice if there was some way for us to make the extended ACL, to make it sort of stateful, like a pseudo-stateful extended ACL. And that's where they came out with, and we'll say 2A, and this was the established keyword. So they came out with the extended ACL, and we were allowed to put the established keyword in there, and that was really checking for the acknowledgement flag. Now, the reset flag would also work, but the ACK flag is really what we're interested in here. In that TCP header, it would look for the acknowledgement flag because that would indicate that if TCP traffic was showing up and there was an ACL configured to match that traffic with the established keyword, it would only allow that traffic through with the acknowledgement flag set. Again, technically the reset flag will work as well, but we're focused on this acknowledgement right now. So that gave it sort of a pseudo stateful capability, because if it's established, then it would be allowed through. And if it wasn't established, meaning there, was no previously established state of the conversation, then it wouldn't be allowed through. Now, there was still no state table, and we were still limited to the layer 3, layer 4 information, right? That source, destination, protocol, port number were still, and again, this would be TCP because UDP isn't established, doesn't establish a connection. So for like HTTP traffic, this would work fantastic. And then Cisco said, you know what, all of these things are good here, but what they don't prevent is a denial of service, or a distributed denial of service attack, specifically known as a SYN flood attack. And then that's where we get into the TCP intercept, And TCP intercept has been around for a long time. And again, this was simply trying to prevent a SYN flood denial of service attack. And it kind of stood out on its own, right? Because it really wasn't a full-blown ACL. It was more of leveraging an ACL, and then you're basically making sure that we don't end up with these embryonic TCP connections where we have step 1 was the SYN from the initiator, step 2 was the SYN ACK, and this would come from the victim, right? And then 3 should be, right, SYN, SYN, ACK coming back from the bad guy, but then this one never responds, never comes back, right? The bad actor doesn't send that ACK, because typically in a SYN flood, the initial SYN packet shows up and it has a bad source IP. So we'll put down bad source IP. And that was good, right? Because that helped prevent these SYN flood attacks. But Cisco continued to move forward. Reflexive ACL, I had to pause and make sure I spell that right. So Cisco continued to move forward, right? And they wanted to become closer and closer to sort of a stateful type iOS firewall. And remember, that's really what we're talking about, right? Is all of this conversation is in the context of iOS, right? So as it pertains to routers, we're not talking about the ASA firewalls or the PIX firewalls. We're talking about the iOS software, right? The Internet Network Operating System that runs on Cisco routers. Because with firewalls, the stateful nature of the firewall has been there pretty much since the inception of the firewall, right? But on a router, it wasn't always there, because initially the idea, and if you think about it, it makes sense, was a router is going to do what a router does, and that is route packets. So it wasn't until you had all the the exploits that were out there, and things being hacked, where it was like, okay, well, we've got to continue to come up with better ways, and then again, different use cases, right? It doesn't make sense, like that example I gave in the earlier video, if you've got a site in Barrows, Alaska and Siberia, that you're going to be sending an ASA firewall along with a router, when for your use case, maybe all you need is context-based access control or zone-based policy firewall. And that's what we're going to be focusing on in this video. So Cisco came out with a reflexive ACL. And the reflexive ACL was great, except, right, it really only worked well when it was well-known traffic, right? And traffic that would behave as you would expect it to behave, like SSH or Telnet, where the port numbers were always going to be what was expected. Where it didn't work well was something like a passive FTP, where you end up with random port numbers for source and destination, or VoIP traffic, H323, VoIP, right? It didn't work too well there. And so then the next iteration, right, and this is from reflexive to CBAC, this was definitely the progression. And Cisco came out with context-based access control, CBAC. And this is stateful, right? This is going to give us stateful inspection. And what we mean by stateful inspection, and let's kind of grow this out, is not only could we look at layer 3, as well as layer 4 traffic, right? We could look at layer 7 application information. And what do I mean by that? And this is really, I'll put a little asterisk here. This is really, when we say stateful, this is what we're talking about. Yeah, it maintains a connection table, and we're going to see that information. But the statefulness of it is the fact that it does a deeper packet inspection at a higher level, where CBAC is actually capable of changing packets if it needs to in a stateful manner, right? So it can actually manipulate traffic if it needs to, because there's really 4 things that it's good at, right? And the first one is obviously traffic inspection. So, because that's kind of obvious, right? That we're going to be able to inspect the traffic. The other thing that it does is we can do auditing. And we'll see this, there's a command line option that we'll be using for audit trail. So it can do auditing, right? It can do intrusion detection. And this is what I was saying. It can actually take, action against, I'll put intrusion detection, detection. It can actually take action by sending a reset flag back to whoever the initiator was. It can send a TCP reset if it determines that the traffic is malicious and basically kill the connection. And so that's what I meant by it can actually manipulate the traffic. And then finally, we can do filtering. Filter. Let's put filter. All right. And so, but again, the key is right here that it does a much deeper inspection. Now, when we go to configure, you can still do generic TCP and UDP, right? But even with the generic, it's going to continue. It does a little deeper inspection than stuff that we were doing with the Reflexive ACL. Because remember, that Reflexive ACL is still kind of focused around layer 3, layer 4 information, right? And the ports and the protocols. We'll put port, protocol, proto. Okay, and so this was the first big step in getting iOS software to act and behave as a true stateful firewall. And so here's our topology that we're working with again today, right? It's the same topology. We want to keep it the same so that it's very simple for us to understand. We've seen it over and over again here. It's router 1, router 2, and router 3. Now, this is going to be my bad actor. In fact, let me do this here. So I'm never really good at changing colors all the time, and I probably should. So this is going to be our bad actor over here. We'll put him in red. And he's going to be trying to access the good guy over here. And this is my, we'll just say www or SSH server. So we're going to be using SSH. It's very easy, right? And again, this is just my host. Okay, it's a router, but it's pretending to be a host. And what do we have? Well, we've got the firewall, or I should say the classic iOS firewall is going to sit right here. So we'll do a little firewall. And that's going to sit right here. And it's going to protect my inside network. And so let me go ahead and we'll do a little demarcation, right? So this is my trusted network. And this is my untrust out here. So we'll say untrust. And in fact, we're going to go ahead and say this is the internet. Now, there are some semantics that are being left out here, and let me touch on those. You'll notice I run OSPF between all these guys, right? And that OSPF is being run simply to provide reachability so that I can get from router 1 to router 3. And you've seen that in my previous videos on this topic. Now, in the real world, you would not be running OSPF if this is, we'll say this is let's do this. So this is the internet, right? And this is your ISP that you're connected to. We'll say this is the ISP that you're connected to, and then I forgot to change colors, and this is probably why I don't change colors a lot. And this is just going to be XYZ Corp. Right? Now, XYZ Corp, if this is a BGP peering, which if you're peering with a provider, there's a pretty good chance you'll be running BGP, or you'd be doing static routes. But in any case, if you're running BGP here, right, that's what you'd be running. You wouldn't be running OSPF. And you would also be NATing right there. On that interface, we would be doing NAT. So that our private network here, and let's just say the private network is 192.168.1.0/24. Now, this is not the network we're using here, but this is just an example, is we would have to NAT to a publicly routable IP address. Okay, so we're going to go ahead and set this up, and we're going to set our CBAC inspection is going to take place right here in the inbound direction, and then we're going to have an ACL on the outside here that is going to deny all inbound traffic. We're going to see how this works. So let's go ahead and transition back here. Sorry about that. All right, so let's go ahead and jump on the command line here and let's make this happen. So the first thing that we want to do is we want to confirm that we have connectivity between router 1 and router 3. And actually we'll go from router 3 here and we'll do SSH -L admin to 1.1.1.1. Now, we should get the password prompt, type in the password Cisco, and as you can see, I'm now connected and on router 1. So we'll go ahead and exit out there, and we'll come over to router 1, and if we can go from 3 to 1, we should be able to go from 1 to 3, SSH -L admin, and 3.3.3.3, and the password is Cisco, and there we go. All right, so we've established that connectivity works, and that's great, but here's the first thing that we want to do. Remember, we take a look at this drawing here, and we want to protect our outside interface, this interface right here. Because again, we're going to go ahead and say that this is the internet on this side. So we don't want to allow any traffic to come inbound that we don't explicitly want to come, unless we explicitly want to come back in, right? And so let's go ahead and do that. That'll be our first step. So we'll transition back here, and for that we're on router 2, right? Router 2 is sort of our border router. So we'll go from user exec mode to privilege exec, and then we're going to do an ACL up here. It's going to be very simple, right? And we're already familiar with ACLs, right? So this is kind of old hat here. So we're going to say IP access list. We'll do an extended ACL, and we're just going to call it outside. How about that? So you've got our untrusted outside network. And remember, we need to take into account the fact that we just don't want to do a deny IP any, right? Because that is going to break what? In this instance here, in our use case. Yeah, it's going to break OSPF. So the first thing that we want to do is we want to permit OSPF, OSPF any. Now, if I was running BGP or EIGRP, right, whatever the case may be, you want to make sure you take that into account. And we'll talk about the router traffic option with CBAC here in just a second, which is sort of like that self zone. So for the traffic being generated, control plane traffic, like this OSPF traffic. So we're going to permit OSPF any, and then we're going to say deny IP any. Now, we're going to log this traffic, and obviously in this case it's not that big of a deal because we want to see what exactly is being denied. What are we denying? And we're going to log that information. All right, so there we go. So we say deny IP any log, and that is our ACL. Now we're going to place it on that outside untrusted interface. So do show IP interface brief, and I need to see, is it GigaO2? Yep, toward router 1, it's Gigabit Ethernet 02. So interface Gigabit Ethernet 02, and we're going to say IP access group. What do we say? Outside, and we're going to do it in the inbound direction. So I'm going to hit enter here. Now we should not lose our OSPF adjacency. In fact, remember those messages we saw in the previous video? We're not going to see those messages here because we've actually allowed OSPF to come through. So we've taken care of this ACL right here. We've protected ourselves by basically blocking all inbound traffic. Now let's validate that that's actually working. And how can we do that? Well, we can come over to router 1, and I can say SSH, let's pull it back up here, SSH -L admin 3.3.3.3. And there we go. Destination unreachable, gateway or host down. But if I say show IP route OSPF, do we still have the routing information? We do. Can I ping 3.3.3.3? No. So again, we're getting that unreachable response with our ping attempt. So we've certainly closed down access. What about telnet? So if I telnet to 3.3.3.3, no, none of that is going to work, right? And so here's where that ACL that we just placed on the outside is doing exactly what we want it to do. But we're not done yet, because here's the problem. I've got the ACL on the outside, and it's protecting me from traffic getting in. But right now, it's also impacting if I say SSH -L admin to the 1.1.1.1. And remember, we know that that works. It's right here on the screen. But when I hit enter, take a look at what's happening. So it's just hanging because we can get out, right? I can get out of the network and I can go towards router 1, right? I can reach router 1. It's coming back that I'm unable to do. And take a look. And this is, I love when things like this happen, right? It really builds the story for you. So take a look at what's going on here. Is the outside ACL is saying it's denying TCP, right? ICMP, there's the ping that was denied. TCP, and this is going to be the 111.333. This last one right here, this is that SSH command that I just ran from router 3, because it's, and the reason it says that the 111 is trying to connect to the 333 is because, remember, if we draw the network out here, right, 3 sends the SYN packet, and this is allowed, right? So this is allowed. The SYN packet is allowed. But what happens is we have this ACL here now that's blocking all inbound traffic. So when router 1 says, oh, hey, great, I've got a SYN packet showed up for destination port 22, that's me, the SSH server, I'm going to go ahead and respond back with my SYN ACK. And the problem is, right now, with only this ACL here, is that that's going to get blocked. And that is what we're seeing right here, is that SYN ACK packet being blocked. And that's a problem, right? Because if we want to run SSH, we need the traffic from our inside network to be able to go out. And then not only get out, but to have the responses come back in. And so this is where the statefulness, the inspection is going to take place. Remember, with reflexive ACLs, how did we deal with this? Yeah, so we put a reflexive ACL here, right? And a reflexive ACL there. And when the traffic came in, it would reflect or mirror the traffic that had come in by simply flipping the source and destination along with their respective ports, and reflected that and put a reflexive ACL entry, right? Sort of auto-magically put that entry in the ACL on the outside interface, allowing the traffic to come back through. But again, that worked if and only if we were dealing with ports and protocols that we were familiar with. Okay, so how do we deal with this with CBAC, right? Context-based access controls. So let me go ahead and clear the screen here. And so we're still on router 2. So now we're going to create our inspect rules. So let's take a look at CBAC. And again, CBAC, this is super, super easy. I mean, it's very, very convenient to set this up. So I'm simply going to say IP inspect, and I'll do a question mark here. And you can see we've got name, and you should see some things that look familiar from the for the TCP intercept, right? Like max incomplete. We've got there's 1 minute, like, so the minute, the watermarks that we're using for high and low in terms of number of connections within a minute. Now, here's something very interesting, right? Remember on our draw up here, right? We kind of did a run up to the technology. When you look at CBAC, CBAC really incorporates all of the previous, and let's change our color here, we'll do a green. It really incorporates everything you're seeing right up to the reflexive ACLs. That is really, whoops, going all over the place here. That is really what CBAC is, because TCP intercept is built into CBAC. So in other words, context-based access control, when you're running it, you are auto-magically running TCP intercept, whether you know it or not. It's there, right? It's part of it. So it took the best of the extended ACL or the standard ACL. It took all the ACL work and the established and the TCP intercept and the reflexive ACL, and it rolled it out into one contiguous feature set called CBAC, right? And we'll see that those options are going to be available to us when we configure the intercept. And you can see that has got to be from the 10.1. Yeah, so from router 1. So it looks like that was sort of a, what's the word I'm looking for? Artifact there. All right, so we're going to say IP inspect, I do a question mark, so we're going to create a name, right? We want to name our CBAC policy. Well, let's just call it trust, right, for the inside network. Now, take a look at this. Now, this is interesting. Now, when we talk about statefulness, this is what we're talking about. The ability to go and take a look at the application layer, right? And so here's where I can pick off applications. And so let's find, where's a good one here? So FTP, right? And this is more than just ports 20 and 21. So it's going to actually look at the segments to make sure that the ordering is correct, right? And it's the same thing here with HTTP and HTTPS. It's more than just port 80 and 443. In fact, we can drill down. Let's do that. So we'll say HTTP, and I'll do a question mark. So we can do URL filtering. We could give a Java list, right, in order to deal with Java. So this, and again, hopefully you're able to see just by looking here that this does much more than simply saying, oh, is it port 80? Oh, is it port 443? No, it goes much, much deeper. So let's put this in here. We'll say HTTP, and we'll do the audit trail. Now that is going to generate log messages when we have traffic that is matching this inspect rule. And so here's what you do is it's kind of like an ACL, or think of the inspect setup, right? The CBAC setup with the inspect commands. The inspect commands are like access control entries, where for each thing that we're interested in inspecting, we want to go ahead and create an inspect statement for, right? Or like an access control entry. So I'm going to say IP inspect name trust HTTP. We'll put the audit trail on. Let me come back here. We'll do a question mark. Let's pick a different one. And let's see what else. So there's your H323, right, for net meeting. HTTPS, and let's see what else we've got here. Telnet is going to be in here. They've got some NFS, right, network file system for file sharing, and SSH. And there's SSH, right, which is what we're interested in. But here's what's interesting, right? Let's see, it should be right here. So TCP, because you're probably wondering, well, what happens if you say TCP and do a question mark? Well, when I have TCP like this, I'm basically just saying inspect generic TCP, right? Now it's definitely going to do it at a deeper level when it can, but this is just like generic TCP. So this would be equivalent to when we create an access control entry in an ACL when we say permit TCP, right? This is just generic TCP. We're not drilling down to the specific application because we're not identifying that specific application. So let's do UDP, because I can do generic UDP as well. And here we go. Let's say audit trail. Whoops, sorry. Because we want it to generate auditing information for us, right? We want to be able to track it. Now, the router traffic option. This option is what you would use for traffic generated, right, by the router itself. In other words, generated by this router, router 2, not transit traffic that is passing through router 2, but control plane traffic. And this goes back to that OSPF conversation, right? But you'll notice that, and here, let me go ahead and turn this on. We'll say IP inspect name trust. If I said IP inspect name trust, you'll notice that if I say OS and do a question mark, OSPF isn't there. What about EIGRP? It's not there. So we would have to handle those in a different fashion. What about BGP? I think BGP is there. Yeah. So BGP is here. And so here's one that would make sense, is if I was running, again, I'd want to be running it on, inspecting on the outside. I could say, BGP, and we can do, or actually look at that. Yeah, so we'll say audit trail and on, right? And so then that would inspect BGP control traffic, right? That would inspect that BGP traffic. All right, so now let's get down to the rule that we want, which is going to be IP inspect name trust. You'll notice we keep using, it's just like an ACL, right? We're just putting access control entries. Think of it like we're putting access control entries into this ACL named trust. But this is how we set up CBAC. And I'm going to say trust, and we want to take a deep look at SSH. And I definitely want to audit that information. And I'm going to go ahead and throw a timeout in here for inactivity, and we'll make it 45 seconds, right? And so that's the rule that I'm interested in. Now, remember, placement is key here. So we've got our, and that's it. I mean, that is CBAC right there. So let me say do show, run, include, inspect, and there it is. Now, remember I said that TCP intercept is also part of the context-based access control. So what I could do is I could also manipulate values that we saw with the timeout. So all I would need to say is IP inspect, and if I do a question mark, this is where those values were at. I could say maximum number of incomplete sessions, and what I'm basically doing here is I'm tweaking the TCP intercept functionality that is already built into, and we'll do the 1 minute, that's already built into CBAC. So if I wanted to say my 1 minute high, we're going to say it's going to be 100 connections, and then from unlimited to 100, okay, and then the low is 100, and I can change the low and say, and set the low to 75, right? And so you can, again, tweak these TCP intercept features that are just basically rolled into CBAC. All right, now, where are we going to put this? Well, if we come back over here, we kind of talked about it already. This is where we're going to want that to reside. Because as traffic is being generated here, coming off my local area network, this 192, we're just going to pretend it's a 192.168.1, right? As the traffic is coming off of this network into this interface, right? It's ingress traffic coming into that interface on the local trusted inside LAN. We want to determine what's going to be inspected, because it's what's going to be inspected that will be allowed back in, because that's going to dictate what is in our connection table or our state table. So connection table and state table, those are synonymous terms when we're talking about stateful firewall inspection. All right, so let's set it up. We'll come back over here. And which interface is that? Do show IP interface brief. And it should be gig 01. So we're going to go into interface gigabit Ethernet 01. And we're going to say IP inspect. And we simply put in the name, right? And we used what do we use? Trust. And in the inbound direction. And that's it. So again, setting up context-based access controls is really a three-step process. We basically lock down the outside interface, taking into account any routing protocols we may be using. Then we create do show run, include inspect. We create our CBAC inspection policy. And again, this is critical because it's only the traffic that we're inspecting that's going to be allowed back in. Anything not listed there is not going to be allowed back in. And there's one sort of, I don't want to say obvious isn't the right word, but there's one glaring exclusion, and I'm leaving it out intentionally right now because we'll add it back in here in a second. So we've added the IP inspect trust in to the inside interface. So now let's come back over to router 3. And we'll say SSH -L, admin, and we'll go over to the 1.1.1.1. Now remember, before this hung up, and we saw messages saying that, hey, the ACL on the outside interface is getting all kinds of hits right now, and it's being denied, trying to come back in, right? The CNAC is being denied, trying to come back in. And that, at the time, was by design. So here's what we want. We want to see a password prompt here. And there it is, right? You got to love it when your plan works. So you get the password prompt, and now I'm on router 1. But more importantly, you can see the little blue yield sign lit up here in secure CRT, meaning something has come to the console port. And take a look. Firewall, right? So here's our syslog message. We've got the facility, which is the firewall facility, the severity, syslog severity level of 6, which is informational, and then a mnemonic to kind of give us an idea, session audit trail start. So start SSH session, initiator, and there is the randomly high port from router 3 that initiated the connection, and here's the responder. Now, here's where we need to take a second and talk about what we saw in chapter 4, specifically when we were looking at sections 423, 4232, and it looks like the session just stopped there. So here's what I should be doing, and it looks like, and we did. So you can see that after 45 seconds of inactivity, right, the iOS firewall said, yeah, no, we're closing that connection down. So here's what I'm going to do, and let me set the enable password over here on router 1. So real quickly, let's just get in the global config and we'll say enable password Cisco. All right, and the reason I'm setting the enable password there, you'll see in a second. So now when I go back and I SSH over to router 1 and I say Cisco, you can see I'm on router 1. Now I want to get into privilege exec, I have to have an enable password set. If I didn't set that password on router 1, the enable password, this would come back and say password not set. So now the password is set, so I can get into privilege exec because I want to say show tech support. Now, this command just runs. It just goes and goes and goes and goes. And I want to do this so that the connection stays up, right? And you'll see it's just going to go on forever here. And that's okay because it's going to give us a second to talk about this. Now, we've got, and that's it. CBAC is set up at this point. You can see we've got the audit trail started. If I was to say show log, right? Are we logging things? And these are going to be messages from the boot. And let's get by these. I probably, hindsight, I should have cleared it, but here we go and take a look. So the audit trail has started again. Look at, we've got a new random high port. Now, with reflexive ACLs, it would look at this and say, oh, okay, well, I'm just going to create a reflexive ACL entry. And it would automatically put that entry into the ACL for you. But what happens here? Let me say show IP access list. Do you see any magical entry here, any dynamic entry being put in here? And this is what's going to lead to the conversation we're about to have. So when you read in the chapter about the classic iOS firewall, specifically there's a multi-step classic firewall operation page. And what did it say? It said that the classic iOS firewall creates temporary openings in the ACL to allow the returning traffic. Well, if that's true, where is that temporary entry? Because let's come back over here. Is this still going? Yeah, and you can see show tech support's a great command to run if you need to be generating output when you're connected remotely. So take a look. It's still running. So where is the ACL entry? And so my point here is that this is incorrect. This is not correct in the text. And we're going to explain why. So CBAC is set up, very easy to set up. How do I confirm that? Show IP, inspect, and what is it? Is it all? Yeah. Show IP inspect all. So here's all the commands we can use, and session is the one we want right now. So there's the established session that I have, right? And you can see that it's that same SSH connection. It even shows you that it's SSH traffic that was being inspected and the session is open, right? And that doesn't stand for session is open. It's I can't remember what that's. It's session something information, I think. But you can read it as session is open, right? So the session is up, it's open. And we know that it's open because take a look. It's generating hordes, tons and tons of traffic, right? And so it's open. But again, show IP access list. Where's the special entry? It doesn't exist. And so this is where the material is incorrect, right? It doesn't actually create a dynamic entry. And this is where we're going to get into a conversation about order of operations, because we have this entry here, right? And that makes perfect sense. That's our connection table, our state table entry, and that's what's being watched. And so let me talk about how the text describes this. So the text says that the following happens, right? And so here's the inside network. The text says that with the inspect here and the deny any here is that when traffic goes out, right? And it's inspected right there. That an ACL, and the book actually even shows an ACL being put on this interface. That is not necessary unless you're trying to limit what is allowed to go through that interface, right? Because here's what the book says happens. The book says is that gig 00, there's an inbound ACL that basically checks to see, is SSH allowed, right? So step 1 is there's an ACL that's looked at inbound. Step 2 is that if the traffic is allowed, it's going to look at the inspection table to see if there's an entry there, right? And that would make sense. Or it's going to look at see if there's an entry there to determine, do I need to track it or is it already being tracked? Step 3, right? And this is where it adds, it says step 3 is it adds that information if it needs to. And then step 4, and this is where it's incorrect. It says it adds a dynamic entry to the inbound ACL here, that there's some sort of dynamic, some sort of dynamic entry that gets put in this ACL here. So my question to you is, why is that not happening? And the answer to this question is because the way that the text is describing this, the course book is describing this, is the legacy way that this used to operate. Because as of Cisco iOS release 12.3.4T, I believe, I'm pretty sure that's what it is, 12.3.4T. As of that release, and I actually have, in fact, I've got the document here. Let me pull it up. As of this release, and it should be right here. Yeah, so, and here's a great document. If you were to Google Security Configuration Guide for CBAC, release 15 M&T, you would find this PDF on the Cisco website. So there's this link right here called Firewall ACL Bypass. And you see a lot of individuals will talk about CBAC and they talk about the dynamic entry that's put in the ACL. That hasn't been the case for quite some time. So here, and you can read this for yourself, right? But the Firewall ACL Bypass feature allows a packet to avoid redundant ACL checks, allowing the firewall to permit the packet on the basis of existing inspection sessions. And if we think about this, it makes sense. Why would I check the ACL first, then check the inspection table? Why not simply check the inspection table first? Because if I check the inspection table first and there's an entry already, that indicates to me that if there is an ACL there, it is allowing that traffic in, because the traffic wouldn't be in the inspection table, wouldn't be in that state table if an ACL was there and didn't allow it, right? So that's the redundant check that it talks about. And again, that is definitely redundant. And so here's where it says it allows the firewall to permit the packet on the basis of existing inspection sessions instead of dynamic ACLs. And if we scroll down here, and this is a great document that talks about CBAC. Again, input and output dynamic ACLs are no longer necessary. And here is the bypass functionality, or the bypass functionality overview. And basically what this is saying is that, and here it is right here, because a matching inspection session is often found in the beginning of IP processing, and I'm going to expand on this, the input and output dynamic ACL searches are no longer necessary. They can be eliminated. And that's the case. Now, this sentence, or this fragment of the sentence right here, because a matching inspection session is often found in the beginning of IP processing. Now, this is one of those sentences that when you come upon it, typically you just continue to read and take it, you take it at face value. Okay, right, whatever. But let's go just a little bit deeper here. What is that talking about? It's talking about the order of operations. Now, this image is really worth its weight in gold. And I'm going to put this in the course section, or you can screenshot it here as well. But what we're talking about is the order of operations for iOS 12.3.8T and later. Now, take a look here. on ingress, which means an inbound packet coming into a router. So if this is, you know, this is kind of our setup right here. We'll look at it like this. Router 1, right? Router 3, okay? So router 3 initiates the connection outbound. Router 1 responds with his CNAC, right? He responds with his CNAC coming back inbound. It's ingress traffic hitting this ACL. And that ACL is basically deny everything. And so let's look at how router 2 is going to assess, right? In chronological order here, it's going to look at virtual reassembly, right? Which is outside of what we're dealing with. It's going to look at IP traffic export, QoS, ingress net flow. But we get down, let's get down to where we're interested in here, is right here. Number 10, input stateful packet inspection CBAC, and we've got this little asterisk. So these operations work on virtually reassembled packet when NAT, CBAC, IP virtual reassembly is configured, so forth and so on. Now, where is the input ACL looked at? Yeah, the input ACL is evaluated after CBAC. And this is exactly what that sentence is talking about. And you can see they've got the little double asterisks here, right? CBAC pinholes bypass the regular input-output ACLs. And you see that's right over here, because here in the output direction, you can see that the ACL is checked before, and this is, again, this is outbound egress traffic, but CBAC it bypasses the regular input-output ACLs. But in the ingress fashion, right, or in the ingress direction, this is what's taking place. And so this is exactly what, and if we go back to this document, this is exactly because a matching inspection session is often found in the beginning of IP processing, right? So it's going to look at that first. So in other words, we now no longer need to spin up a dynamic ACL to change that deny any ACL on the outside. We no longer need to do that. That's no longer the case, and that's been the case since I think about 2007. So I was surprised that the text talked about the addition of that dynamic ACL entry and changing it, because that is not what is happening. In fact, if we scroll down here, and there's the command that we just took a look at, right? Show IP inspect session. You can use the detail option at the end. And so here's the old information. And take a look. With the old information, yeah, it did dynamically, auto-magically manipulate that outside ACL that was denying UDP and TCP, but it was permitting IP any. But you can see that it would change the ACL. But here's the new information. And let's go run that command right now with the session detail. So we'll say inspect session detail. And so here's our information, right? And did it finally run out? I think maybe the tech support, yep, and the connection closed out just in time, right? So perfect timing to come back and see that. Take a look at this. It tracks now. We've got a session ID. We've got a time as to how long ago it was created. When we last heard any traffic was 42 seconds. This was 3 seconds later. There's our 45-second timeout. You've got a byte count, right? How many bytes has the initiator sent? How many bytes has the responder sent? And then we've got our session ID here, right? Take a look at this information on ACL outside. So, and this is what's really going on, right? You can see the session ID on ACL outside. And this is what's allowing that traffic to come back through. But it's checking this information first. Then, if there's no state table information, right? If there's not an entry already in the CBAC state table, then it's going to assess that ACL for ingress traffic. So like if I was to telnet, right? If I was to say telnet to, what is it, 1.1.1.1. I don't think we're allowing telnet. So you can see I'm trying there. And actually, am I even inspecting? Whoops, show IP inspect config. Show IP inspect config. So we'll take a look here. So yeah, so we're not inspecting that traffic, right? So does the traffic hit router 1? Let's see if that traffic even makes it out. So we're going to say, oh, I got a password on here now. So we'll say debug IP packet detail. And let's kick off that telnet session again. And let's see if the traffic makes it over here. And it does. And you can see TCP source and destination is 23. So the traffic's getting here, but you'll notice that the traffic never makes it back. It's being denied by the ACL, but we're not seeing it hit the ACL. And you know why? It's because the source showed up as the 10.1. So let me see if I can do, we'll let this time out, and let's see if I can tell that. I think I can tweak the source here, 1.1.1.1. And can I change the source? Source interface, there it is. So we'll say source interface, and we'll use loopback 0. All right, so now we're using loopback 0 as our source interface. Now it lights up here, right? Because if I didn't use the loopback interface, it's going to think it's coming off of the egress interface of the router, but we want it to come out from the 3333, not the 10 dot whatever. And so take a look. So what got hit here? Is it the CBAC state table that's denying this? No. Again, it's checking the CBAC state table to see if the entry is, if there's an entry there. Was this traffic inspected? Are we inspecting telnet traffic or TCP generic traffic in general? And the answer is no, we're not. So it checked the state table. The state table said, yeah, I'm not inspecting that traffic going out. So, no, pass it down the line to where we hit step 12 in this image right here, and it says input ACL. And then the input ACL is what matched. And you can see denied TCP traffic for port 23 because it's not being inspected. All right, so let's wrap things up here with a brief review of what we've covered so far with CBAC. So CBAC basically is the best of both worlds here. It's all the ACLs, and I'm kind of running out of color choice. We'll go with yellow here. Actually, let's stick with green. It's the best of both worlds, right? It's got TCP intercept built in. It does everything Reflexive ACLs did and more, right? It goes down to the application layer. We saw how easy it is to set this up. I mean, imagine if you had a remote office and you were like, hey, we need to implement, an iOS firewall because we've only got room for the router. We're only shipping the router up there. We're not sending a bunch of equipment. CBAC is a great way to do it. Now, I'm going to give you the preview spoiler alert for topic 6, which is going to follow this one. We've got a packet tracer activity for this. Zone-based policy firewall. And here's the dirty little secret, is that zone-based policy firewall, the configuration commands are different, right? The interface within the context of how we configure it is different. But under the hood, zone-based policy firewall is nothing more than the same engine that CBAC is using to inspect traffic. So the only thing that changed, right, and there's some significant differences we'll talk about, but the only major change here is that the syntax that we use to create it and the fact that CBAC is interface-based, because you saw how we put it on the interface. It's based on an interface level. Zone-based policy firewall is zone-based. And the difference is this. So think of it like this. What if I decided, you know what? On the inside here, I want to put a DMZ in here. And over here, I want to put, we've got some partners. I'm going to put a partner zone, right? Now, what ends up happening? Yeah, you can see it doesn't really scale too well. Or what if I add another interface here that's supposed to be in the same zone as these guys with router 3, right? It's supposed to be in the prod zone. You can see the problem that we have, that the interface-based approach, which is what CBAC is, and this was the catalyst behind zone-based policy firewall, right, was that this interface-based model didn't really scale all too well. But again, you have to take use case into consideration. If this is what your environment starts to look like, where you've got a partner zone and you've got a DMZ and you've got, you know, another prod zone, maybe you should be looking at a firewall at that point. Maybe that starts to make sense because, again, CBAC's not going to scale really well. But in that Siberia example that I gave you, how easy is it to set this up? I mean, CBAC is a piece of cake to configure. You saw we get auditing information, we get alerting information, and it's very quick and simple, and it includes TCP intercept. But we're now going to transition our conversation to zone-based policy firewall. We're going to see that there's a different syntax. It uses sort of the QoS syntax, and you'll see what that, you'll see what that means when we get there. It's like C3PL, I think is what they refer to the language. We're going to create a class map and then a policy map, and they're going to be of type inspect. But the syntax changes, but most importantly, we now just simply take the interface and say, hey, you're in the DMZ zone, and all of the policies in the DMZ zone apply to you, or you're in the inside zone, right? It's a zone-based model as opposed to an interface-based model. But to wrap up the CBAC conversation, we saw that it does a deeper packet inspection at layer 7, and we can pick the applications that we're interested in. HTTP was an interesting one. You could do URL filtering if you needed to. But CBAC is very simple, easy to set up. And the key takeaway, remember this, is that the classic iOS order of operations, it does not put some entry into the existing ACL, and we saw that. And in fact, to close that part of the conversation out, let me transition back here just briefly to that PDF document, which, where did it go? There it is. You can see here the additional references, and it showed us what it used to look like. Right here, yeah, that is, it was 12.3.4t. So the Firewall ACL Bypass feature allows a packet to avoid redundant ACLs or ACL checks by allowing the firewall to permit the packet on the basis of existing inspection sessions instead of those dynamic ACL entries. And this is on. You don't have to do anything to turn it on. This is the default behavior, and it has been the default behavior since 12.3.4t. Right? So this is a great document. If you're interested in CBAC, this is a phenomenal document, right? But remember that it's not creating these dynamic entries, okay? It's checking the session table first. All right, guys, well, this is going to wrap up the supplement on classic iOS firewall. And we've walked our way. We're just about to the top of the iOS firewall mountain, and we're going to be there when we cover zone-based policy firewall. All right. Thanks so much for watching. I hope this has cleared up any confusion you might have had about the context-based access control iOS firewall, what it is, what it does, how to configure it, and all the things that we can do with it. And now we are on to zone-based policy firewalls. Talk with you guys soon.